Each year, the Royal Observatory Greenwich hosts an Astronomy Photographer of the Year competition, and to celebrate the craft and skill of the entrants, we're going to be taking a closer look at subjects within astrophotography. Today, let's talk about solar astrophotography. This competition image of the solar surface, called liquid sunshine, represents a particular difficulty for an astrophotographer. Usually, we're concerned with distant, extremely faint objects, and our main concern is making any detection at all. But that's not the case with our sun. In fact, even on a rather dreary day here on Earth, at a distance of roughly 150 million kilometers, the sun is still too bright to look at directly. One of the biggest problems is the excessive amount of light, and taking pictures of the sun safely generally involves blocking out all but a tiny fraction arriving at your telescope. Here, at the Royal Observatory Greenwich, we have a long history of solar astrophotography, which we continue to this day. The Annie Maunder Astrographic Telescope was named in honour of the pioneering female astronomer who worked at the observatory in the 1890s. One of its components is a dedicated solar telescope, allowing us to produce images like this. Here, we have captured just a small part of the spectrum of different types of light emitted by the sun, a region known as H-alpha. By filtering all but specific wavelengths of light, we get a particular and safe image of our sun. However, different physical processes produce radiation at different wavelengths, and the sun, though it seems like a constant fixture in our daytime sky, is a dynamic star. What we call the surface of the sun changes from moment to moment as hot gases rise, sink, and are even emitted as a result of the constant churn of solar weather. This means that by viewing the sun through a different filter, and so allowing different wavelengths of light to be captured, we can take a rather different image. Here you can see an image taken using a type of light called calcium K, with the brightness inverted to create what has been titled as a ghostly sun. This combination highlights the apparent edges of the sun from this perspective and shows clusters of sunspots, regions of cooler sinking gas, as little bright spots. These basic principles perhaps hide how dedicated astrophotographers are to create amazing images of the sun, or how much variety there is out there. In this image, called tower-like prominence, rather than focus on the main spherical body of the sun, instead, the most prominent visual feature is the enormous emerging loops of plasma, approximately 150,000 kilometers tall. Let's finish with a final look at liquid sunshine. Despite being taken during a solar minimum, a region of time when we see significantly less solar activity, such as sunspots and solar flares, we still see the constant motion of the solar surface, as cells of hydrogen around 1,000 kilometers wide warp and shift, their delicate appearance disguising the awesome power of our parent star.